Hi everyone, in this video we are going to learn about polar coordinates. So polar coordinates are plotted on what's called the polar coordinate plane. I have a picture of it here. Alright, so on the polar coordinate plane you're going to notice that it's circular instead of rectangular. So the XY plane had rectangular boxes, right? Now we're dealing with circles. Alright. The pole is this point here in red. I'm just going to darken it a little bit. Okay, right here, this is called the pole. So the pole is like where the origin would be in a Cartesian plane or rectangular plane. Okay, so the pole in the polar coordinate system is the same as the origin in the Cartesian coordinate system. So Cartesian and rectangular are the same. It's the coordinate system that you've always graphed on. Okay, and again, it's this red point here. It looks like the origin from the rectangular. Then we have what's called the polar axis. So the polar axis is the positive, or what would be the positive x-axis in the Cartesian coordinate system. And these two things are needed to plot points. We're going to have to reference from the polar axis and from the pole. Okay. So the polar axis is shown in the same position as the positive x-axis in the Cartesian coordinate system. Okay, so those are the two important parts you're going to need here. Now, we're going to start plotting points. On the next slide, I'm going to show you how the point would be written and what it means. But you will be referencing to the pole, because the pole, you're going to go out the r value from the pole, and for the angle, you're going to measure the angle from the polar axis. Alright, so let's see what the point would look like in general. Okay, so a point sorry about that, a point in polar coordinates is written as the ordered pair, so it's still an ordered pair, r theta. Okay, so instead of xy, now we're going to have r theta, where theta is the measure of an angle in standard position whose terminal side contains the point. R is the displacement and displacement just means directed distance from the pole to the point in the direction of the terminal ray of theta. An important note here is that theta is the independent variable. So we're so used to the independent variable coming first, like in an xy point, x is the independent variable. But here in polar coordinates, r theta, theta is actually the independent variable, not r. Okay, and again, that's even though it's second in the ordered pair. Okay, so a couple important notes before we start plotting a point. So you're always going to be given the point as r theta. Theta is the angle measured in standard position. Now, standard position is going to be from that polar axis because it's from the positive x-axis in the Cartesian plane. R is the displacement, and it is a directed distance. So if r is negative, we are going to go in the opposite direction, and I'm going to show you that. Again, theta is the independent variable, not r. Okay, so those are the important notes from here, and now we'll start actually plotting points. Okay, so let's say I have the point two comma pi over 4, and I want to plot this. Okay, because theta, remember it's an r comma theta point, because theta is the independent variable, you're going to go to pi over 4 first. So here's our pole, and here is our polar axis. Now this particular coordinate plane is already labeled with our radians. If it wasn't, you would just have to figure out where it is. Okay, so I'm going to go to pi over 4, which is here. And then from the pole, I'm going to count 2 points out because it's going to be a directed distance of 2. So from the pole, I'm going 1, 2, landing at this red point. So that is the point 2 comma pi over 4. Now you're probably already thinking that this point could be written a ton of different ways, and it could, right? So another way we could write this point is doing it from the other way, like a negative angle instead of a positive angle. So if we did that, then the point would be 2 comma negative 7 pi over 4. That's the same exact point. That's going to land you in that same spot. Okay, we can also do something coterminal, maybe not in the negative direction, but in the positive direction, right? No one said you have to only go around the circle once, right? So you could also say that this is the same as the point 2 comma 9 pi over 4, because that will land you in the same spot. Okay, something a little bit different that will also land you in this spot would be having r as a negative. So if r is negative, negative 2, what's going to happen is instead of going along that angle, you're going to go in the opposite direction of that angle. So for instance, if I was at the pole and the point was negative 2 comma pi over 4, what's going to happen is I go to pi over 4, but instead of following that line, I'm going to go in the opposite direction of the pi over 4 and go 1, 2, in the opposite direction. So the blue is actually this point, negative 2 pi over 4. Okay, and then that point you might realize is the same as 2 comma 5 pi over 4. So going back to my original red point, if I wanted to, right, these are all equivalent. The the black and the two reds are equivalent, and then the two blues are equivalent right now. If I wanted to go back to the red point and make an equivalent point, meaning it lands in the same spot, that has a negative r, I'm going to do -2, 5 pi over 4. Because what will happen there is I would go to 5 pi over 4, which is here, and instead of going 2 in that direction, I'm going to go in the opposite direction, 1, 2, which will actually land me at the original angle of pi over 4. Okay, so when your r value is negative, you're going in the opposite direction. Okay, let's try another point. So let's say I want to plot -3, 5 pi over 3, and I want to name the point two other ways. So I want to name the point -3, 5 pi over 3 in two different ways as well. So first I'm going to find 5 pi over 3, which is here. Go to the pole, and instead of going 3 in this direction, I'm going to go in the opposite direction. So I'm going to go 1, 2, 3 in the opposite direction of 5 pi over 3. So I land here at my green point. Now I want to name the point two other ways. Well, one way is easy. I could just do the point 3, 2 pi over 3, because that's where I landed. Right? With the positive r value, I would just go along 2 pi over 3, and that's the point. Okay, the other way, I can do something that's coterminal with the original, something coterminal with the one I just came up with. So I'll just do with the one that I came up with. So coterminal with that would be I would have to add 2 pi, which is the same as adding 6 pi over 3. So when I add 6 pi over 3 to 2 pi over 3, I get 8 pi over 3. So that's an equivalent point as well. So all three of these would give you the same point. And that's plotting. Now the next thing we have to do is go from polar to rectangular, and then rectangular to polar. Okay, so first we're going to do polar to rectangular. So I'm just going to plot, I don't have the polar coordinate plane here, but I'm going to sketch the graph or the point 4, 45 degrees. This is in polar coordinates, right? Okay, so if I plot this, I know, again, I don't have the polar coordinate plane, but I do know that I would start at the pole, I would go to 45 degrees, which is about here, and I would go out 4. Okay? So this point here would be the point 4, 45 degrees in polar coordinates. And I want to change this to xy. I want to convert or transform to rectangular coordinates. Okay, well, rectangular coordinates would be equivalent to this point's x and y values. Right? So I just need to figure out, okay, what's this x value? Okay, let's call it x for now. And then what's this y value? We'll just call it y for now. Okay, so now looking at my diagram, I did just form a right triangle, and I have one of the angles and the hypotenuse. So if I wanted to figure out x, I see that I could figure it out using one of the 6 trig functions. Okay, so the 45-degree angle is here. X is my adjacent side. 4 is my hypotenuse. So that means x over 4 has to equal the cosine of 45 degrees, because cosine is adjacent over hypotenuse. To figure out y, y is the opposite side of 45 degrees. So that means y over 4, or the opposite side over the hypotenuse, would equal sine of 45 degrees, because sine is opposite over hypotenuse. So now if I can just solve these for x and y, I would have the rectangular coordinates, right? So let's try to solve these. So I would multiply by 4, and then I have x equals 4 times cosine of 45 degrees, and now your brains are going to go back to the unit circle, because remember I said the unit circle is never going away. And we would have to just think of what's the x coordinate at 45 degrees on the unit circle. That is root 2 over 2. So my x coordinate here after simplifying would be 2 root 2. For y, we're going to solve the same way by multiplying by 4, and I get y equals 4 sine of 45 degrees, which is y equals 4 times the sine of 45 degrees. That is the y coordinate on the unit circle of 45 degrees, which is also root 2 over 2. So y is 2 root 2. So my rectangular coordinates that is equivalent to 4, 45 degrees in polar coordinates is going to be 2 root 2, 2 root 2. And that's my rectangular coordinates. Now we're going to do the other way. So the other way would be going from rectangular to polar. So let's say in rectangular coordinates I had the point 6, negative 6. This is in rectangular, and I want to convert to polar. Okay, so I'm going to just plot this really quick. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, negative 6 there. So here's my point. Okay, this again is the point 6, negative 6. All right, so what we want is we want to figure out what angle this is at, and we want to figure out how far it is from the pole, because those are the two things you need for polar coordinates. So we can figure out the distance from the pole. First we have to kind of draw it in. All right, this is the point 6, negative 6. So that means I traveled negative 6 down and 6 to the right to get there. What I want to figure out is theta, which would be from here to here. That would be my theta. And r is going to be how long this directed distance is. So from here to here. All right, I have a right triangle. So we know we can find the hypotenuse of any right triangle by using Pythagorean theorem. So that means that r is going to equal the square root of 6 squared plus negative 6 squared, which means r is going to equal the square root of 36 plus 36, or the square root of 72, which can be simplified to 6 root 2 because 72 can be broken into 36 times 2. So that's my r value. That was pretty easy to do just by making a triangle. To figure out the angle, what we're going to want to do is use the arctan, because we have the opposite and the adjacent. The reason we would use arctan and not tan inverse is because we need to figure out which quadrant it is in also, right? So if we just did tan inverse, it might not put us in the right quadrant. So I'm going to do arctan of the opposite, which is negative 6, over the adjacent, which is 6. So that means I'm doing tan inverse of negative 6 over 6 plus, and if you recall from when we did trig for arctan, we're adding 180 degrees n. Okay, so tan inverse of negative 6 over 6, that's actually negative 45 degrees. And then I have to decide whether or not I have to add 180 degrees n. So negative 45 degrees, that is in the right quadrant, but if you want it to be positive instead of a negative angle, you could add 180 twice and get 315. Up to you. You can use negative 45 or 315 here. Okay, so the way that we would write this in polar form, the r value comes first. So it would be 6 root 2 comma negative 45 degrees. Or again, you could use 6 root 2 comma 315 degrees. And that's our polar form for this rectangular. Okay, in the next slide, I'm just going to give you this more formally so that you have how to convert. Okay, so if a point with Cartesian coordinates xy has polar coordinates r theta with r not equal to 0, that wouldn't make sense, then, okay, and these are all the relationships I just showed you. R squared equals x squared plus y squared. Okay, x over r equals the cosine of theta, which equivalently is that x equals r cosine of theta. Y over r equals sine of theta, and equivalently y equals r sine of theta. And tangent of theta has to equal y over x, that opposite over the adjacent. So this is basically what I use to change the points back and forth. And you could use these as well. You could draw the picture and just reason through it like I did in the beginning, or you can use this. All right, so in this video, what we learned was how to plot polar coordinates, how to get equivalent points, and how to convert from polar coordinates to rectangular coordinates and rectangular coordinates to polar coordinates. All right, and now you should be able to do the assignment. Thank you for watching.